I've been working on diseases of the retina for the last 50 years, and in particular concentrating on those diseases that are manifest as a result of aging. So currently we have age-related macular degeneration as the most common cause of untreatable blindness throughout the world. The form of advanced AMD is treatable with drugs, but unfortunately that's 10% and you're not treating the disease, you're treating an end-stage complication. So what we are currently doing is treating the etiology of the disease. We're actually interfering with the aging process using a laser and doing it in such a way that we essentially rejuvenate the retina. So the retina never gets to the stage where we see age-related degeneration. We have a novel laser called 2RT, and the novel aspects of this laser are first that it uses a nanosecond pulse of energy, and secondly that it uses a special beam in which the distribution of the energy is essentially speckled. So by using this, we have the best of both worlds. We actually generate the chemicals which cause cleaning up of the outer retina and its rejuvenation, but at the same time we preserve sufficient number of cells that there are no degenerative changes in the retina that's responsible for seeing, so the patients don't lose any vision but actually gain from the treatment. 2RT is a laser which has evolved out of a lot of research over the years. The initial lasers came in the early 70s, and these used millisecond pulses which generated heat profiles which went all through the retina. Over the years we've tried to reduce that, and so we've seen people reduce milliseconds to microseconds. But we've taken a major step forward with 2RT to produce a nanosecond system. And in doing that, we've gone from what was in the past a thermal process to a disruptive process, a totally different process for producing the therapeutic benefits. The major difference is in the responses for the patient. With a conventional laser, you will always get some collateral damage to the light-sensitive cells. So in a sense, you're producing an effect which is actually in contradistinction from what it is you're trying to do, because you're killing the very cells that you're trying to preserve. With 2RT being this disruptive mechanism, we have no collateral damage, and therefore we get the therapeutic effect with none of the collateral effects of damage to the light-sensitive cells. There is a confusion in the minds of many of my colleagues, and that is subthreshold and 2RT. Subthreshold is an attempt to produce lesions which you can just about see or you can't see, but those lesions, subthreshold lesions so-called, will have collateral effects and damage the light-sensitive cells. Albeit less than we used to, but it still causes some damage. With 2RT, that whole issue goes away because we're only producing damage in one layer of cells, and the therapeutic benefits are generated from that layer, but we're not causing any collateral effects to the light-sensitive cells other than improving their function. Laser treatment of the fovea is a little bit controversial and is not really necessary if you have a laser which produces sufficient therapeutic effects and sufficient diffusion that you get a corrective effect, a rejuvenation throughout the entire central area. You don't need to treat the fovea. I think 2RT has an incredibly interesting future. I think it will be the treatment modality as we go forward, and its cost savings for various government authorities will be huge. But at the same time, the benefits for the patient group will be enormous. For the first time, we're treating the 90% of AMD patients that previously weren't treated. So yes, great future.